Hello and welcome. I'm your host, Adam Hawkins. This episode is a small batch of software delivery education. If you enjoy this episode, then share it with your friends and colleagues. Hey everybody, welcome to the next episode of Small Batches. This is Adam here. I'm going to try something new for this episode. Usually I write the scripts for these episodes. It takes me about a week to 2 weeks to write one. I do iterate on it quite a bit, trying to get it, just how I want it to fit into the kind of like 5 to 7 minute window. And I do this because I want to provide you with something that increases your knowledge. Like it brings you to a higher percentile understanding of a topic you've may not heard before. I think that format works well for things that I can explain in that time that don't really require a lot of context or sometimes like real discussion of trade-offs or these type of things. So for this episode, I'm going to try something new because the topic I have doesn't really fit that format, but I think it's something worth discussing. So what I'm going to do here is I'm just going to do this live. Try to give you a feel for what I think, kind of more of a sort of a conversational style as opposed to just me reading off of a script. So the topic for today's episode is dev environments. This is something that's been really important to me as a developer, as somebody who writes software and has to, interact with these environments and do work. And also as a site reliability engineer, kind of a, sort of a more of a DevOps and backend kind of ends up working in, say, a vertical team or a horizontal team. And in my experience as a member of a horizontal team, we tend to get tasked with operating and building and, overall maintaining these sort of common resources. And the dev environment falls into this bucket. And in my experience, I've encountered a lot of different dev environments, some good and some bad. One of the problems or sort of the decision criteria that's come to influence my thinking a lot is the way that we as software engineers go about developing the individual services that we work on. And I say individual services because when I think of software, I always think of more than one service, because the natural progression of software is to grow beyond the single code repository or the single service that it starts. I think many of you, and I know I fall into this category, have had experience building software that started off as a monolith, and then over time, things changed. Maybe the business became more successful, the business grew, the team grew, there was more people, and then there's a natural desire to try to say, okay, hey, maybe we can split this off, some of these things, so that, this team of people can work on X and these people can be responsible for Y, and we can move towards a more independent and autonomous teams. But the challenge there is actually deciding as an engineering team how to approach the problem of dev environments, which speaks to the problem of how are individual services constructed and how do they communicate, and what assumptions does the engineering team make just about how they're developed. And the choice here, or like the set of choices the team makes, will last for a very long time. Now, I don't know how many of you have participated in, greenfield projects or even complete startup starting from zero. And regardless of whatever the timeline is, the decisions made, the fundamental decisions about how software is constructed, they tend to last a really long time. They may certainly outlive the founding engineers of a company or the first people who made the initial design decisions or whatever. You might see choices that were made, X number of years ago, and the people who made them, they're not even part of the company anymore. You can't even ask why the things were done in this way. And, in that case, maybe it just proceeds as the status quo, and that's all there is to say about it. And people don't question it. Or on the other hand, maybe you have engineers who are just more experienced, more practiced. They understand the trade-offs and take a more rigorous approach to building the system or thinking about how different components in it interplay. And the outcomes in these different scenarios are different. So I want to set the stage kind of by talking about this problem and thinking about the different ways that teams can approach this. My perspective here is coming from joining teams that already have, they're sort of, established in the sense that they have had engineers working on their product for a few years. The business is running, they're growing, and they're not really worried about, say, running out of runway or folding in the short term. So the perspectives there are kind of short term, medium, and long term. In my experience, there comes an inflection point where a team who may have, a monolith will decide to make their first service, something I just spoke about a few minutes ago. And then the choice is, how does the development environment work for this service? Now, when you have a monolith, this is pretty straightforward, right? You can start up the running application, it connects to the database or whatever. Maybe it doesn't even depend on some kind of external services or like external APIs. And, you just develop it, and it doesn't really force you to consider certain things until the inflection point. This will happen. The team decides to make the first service outside the monolith. Then, just kind of by nature of the existing architecture, likely this new service will depend on something in the monolith in some way, shape, or form. The question here is, if I want to develop this new service, let's just call it service A. So if I want to develop service A that depends on the monolith, in the development environment, is service A going to talk to the monolith? There's only two answers to this question. It's really a Boolean choice. So if the answer is either yes or no, this is where the inflection point is. If the team decides yes, that it will talk to the monolith, then what this implies is that now for somebody to develop service A, the monolith must also be running. Okay, doesn't really seem so problematic, because most people in this team are probably used to running the monolith, and they can run service A, and it's not really a problem. It's small enough scale, right? Then service B comes along. Now the question is, what does service B depend on? Does service B depend on service A? Does it depend on the monolith? Do you repeat the same choice? Okay, well then, now let's say that to develop service B, now service A is running, and then the monolith. And if you extrapolate this out a bit, you end up in a place where, in order to develop one service, you may have to start every single service just to do that. That's problematic for many reasons, which we'll get into in a little bit. So this is one answer to this choice. Now, the other answer to this choice is, well, to not talk to any of these external services. And that might sound sort of like maybe heresy in some way, because you might be thinking, well, how do I know that my service is working with this other service? I have to test them together. Well, okay, let's tease that apart a little bit. Now, there's two parts of this. One is this service behaving correctly with regards to its interactions with external services? this question can be answered completely with a test suite. So, following standard software engineering practices, if you have an external dependency in your test suite, and let's consider this as a network service, something like that, you're not going to actually make those network calls. You're not going to call out to an external service in your test suite. I mean, that would just be ridiculous. So what you do instead is you use mocks and stubs as a way to test that you, as the consumer of this external service, are calling it correctly, and that the return values are handled correctly, and you handle air conditions and these things. That gives you the confidence that your code is in fact behaving correctly as defined by the specification of this external service. So if you can hit that point and say, okay, yeah, this service is working as defined, good. Then if you take that, I think it's safe to stipulate that the external service is also performing as expected by the API contract. Then you could have the confidence to push up the service to some kind of staging or other environment where you can further validate your assumptions. Now, the key difference here is that you're not relying on a fully integrated development environment to do minor changes, because you just don't need it. That's what the tests are for. Now, there is a small caveat here in that you still do need to start and interact with this application for some use cases. Say you're developing the UI. You can't do that with TDD. You actually have to start the application and interact with it, muck with changes, muck with CSS or, whatever. You have to actually see this with your human eye. So given that your code is already factored such that the interactions with this external service can be replaced with mocks and stubs, then in development, you can replace the external dependency with a fake. This fake might be just like a simple in-memory implementation. It could be just a hard-coded implementation that always returns the same values. Could be a Docker image provided by the team who developed the external service that you could run locally and point your application to. But the point is, it's not connected to a fully integrated running environment, because you don't need that to prove out the independent correctness of an individual service. Now, these are just two answers to this problem. So I refer to this as the isolated environment versus the integrated environment. In the isolated environment, individual services are completely detached from external dependencies, save like data stores and things that are fully owned by that service. I'm more referring to external services that you may interact with over the network, like external APIs, things like AWS, blah, 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 that are not inside the service's bounded context. So in the isolated case, the services replace external dependencies with mocks and stubs in the tests and fakes in development. In the integrated case, the code base may replace the external services with mocks and stubs and tests, which I think they should be doing anyway, because that's the only way to produce a reliable test suite. But they may rely on the access to running versions of all the dependencies to create a fully integrated development environment. And I think that's just a bad decision. I mean, a really bad decision, especially in the beginning, because there will always come an inflection point where that decision is no longer tenable. Now, earlier I mentioned that, okay, yeah, you do this when you have one or two services. You have a small team, everybody sort of knows all the different code bases, and you're all more or less working together on these things. But if you take this approach and extrapolate it, what happens when you have 5 services? What about 10? What about 20? What about 30? The same thing can be said about the number of engineers in the team, or even the number of teams, right? So let's just extrapolate for a second of what if you had 20 engineers, 40 engineers, 80 engineers, 100 engineers, or, one team and then 4 teams and 8 teams and 12 teams and so on. And is it really a fair assumption to think that every person in the organization or every developer in the organization should be expected to know how to run and integrate every service? Because that's what will happen if they depend on each other. As more services are added, if you imagine the topology of services as a graph, talking a graph in terms of a directional graph with nodes, that there will be more nodes, the connections will become more complicated, and that you will not be able to work with one node without the presence of everything in the graph. And even if you discount the human factor of making one person trying to figure out how to do all this, or even, more annoyingly for people like me, pushing it onto some kind of horizontal support team who may or may not even be familiar with all the individual services, but still somehow responsible for managing and creating this sort of quasi responsible for integrated environment, but also consider compute resources. Let me tell you a story about this one. So this happened to me at a previous company where we had opted for the integrated approach, and it was kind of okay for a little bit. So then what happened is it was working, and we never thought about this before. But when the company decided to hire a whole bunch of new engineers, they opted to purchase machines with half the RAM that everybody or the previous engineers had. And this created a problem almost immediately, because now the new engineers simply did not have enough RAM to run everything on their machine. And when I learned about this, I was, really frustrated, and, there wasn't really another option in the short term besides buying more RAM. And, unfortunately they had purchased Macs. And as you know, you can't really upgrade the RAM in a Mac, especially a MacBook Pro, a Mac laptop. But then, the whole assumption that the developers would be able to start and run the system on their own machine for their day-to-day development tasks completely and utterly fell over because of this. And as a team, we honestly were not prepared to come up with a different solution. I mean, we had never even thought that this could happen. And it was something that just was foisted upon the team because of some decision made, in a completely unrelated area. Now, I'd bring this question up of integrated versus isolated development environments because it's a fundamental engineering decision that will have long-term ramifications for every single developer who joins the team, and how new services are constructed, how testing works, and how development works. I have a clear preference between these two choices. To me, it's isolated environments through and through. I think anything else is, a regression that should be avoided, especially by, frankly, senior engineers who should know better. If given the choice, they should not choose to create systems designed in this way unless there is some, externality or some really important factor that requires this. I'm not sure if, you've been part of a team who's ever considered this question, or been part of a team who has either ever been part of a team before this inflection point or after. So I encourage you to think about this, kind of if you are in a team who is currently working with the assumption that they'll have a fully integrated development environment. I think it's worth having a conversation in the team about ways to isolate them and reduce the amount of dependencies in the environment, and really look at why why the team is working like this. I think there are plenty of benefits from going to an isolated approach, namely fast, reliable, and independent autonomous development environments that can be completely owned by the teams responsible for those code bases and just not relying on anything outside the system in question. But achieving that, of course, is something that's not trivial. And maybe that's why it doesn't happen. It requires teams to stick to rigorous engineering practices of separation of concerns, using things like hexagonal architecture to be able to replace versions of external services with different implementations depending on the context, right? It requires the team developing a service that consumes another service to develop maybe a fake version of that dependency that they can use in their development environments. But it might also mean that teams who produce services also ship fakes for use by other development teams, such that every development team who consumes that service doesn't have to create a fake themselves. There are some benefits to using fakes. One thing I like to do with them is create all kinds of weird air conditions that you may not be able to replicate in a different environment. Like, say, for example, adding latency spikes or returning junk data randomly. There's all kinds of fuzzy conditions that you can force through a fake that you cannot necessarily force in a live environment. And I like doing this because it gives me, the developer of the service, the means to really test and verify that my service is operating correctly in all of the conditions I can account for, and thus free of regressions, without having to worry about something breaking on me in some externality that I'm just frankly, I don't care about at that particular time. Like, I'm just working on service A, I'm developing it. I don't want to have to know that I need to have this whole world running and all the problems that creates, or just to do my work. I like to be in a small little box where I can iterate quickly, reliably, and produce consistent results. And I don't think an integrated environment is a way to do that, especially in a growing team. I just know that this approach falls over completely in a sufficiently large team. That's my thoughts on the choice of integrated versus isolated dev environments. Thank you for staying with me through this whole episode. It definitely is not as short as they're used to. If you like this format, then let me know, and maybe I'll do more like it. Thanks for listening. That completes this batch. Visit smallbatches.fm to subscribe to the show for free. Would you like a topic covered on the show? Then call +1 833 933 1912 and leave your request in a voicemail. Hope to have you back again for the next episode. So until then, happy shipping. Want to learn more about DevOps without wasting your time? Then sign up for my free email course at freedevopscourse.com. My course combines the best from the DevOps Handbook, Accelerate, and years of software delivery experience. You'll learn the 3 ways of DevOps and the 4 KPIs of software delivery performance. More importantly, I'll show you how to put that theory into practice. That means shipping better software faster. Sign up today at freedevopscourse.com.